Okay, in this video, we will be solving this problem right here, where we have a quaternary mixture of compound A, compound B, compound C, and compound D. This mixture obeys Raoult's law, and the molar composition is given here. It has a fixed total pressure of 4 bars, and we want to know what is the bubble point temperature of the mixture and the vapor composition that results. So we want to know bubble point temperature as the first step. We're also given vapor pressure for the pure species, given Antoine equation here. And just as a side note, bubble point mixture, the formula that we will use is this, and the vapor composition formula is this. And so we're ultimately going to solve for bubble point temperature using this equation right here. This is the first equation. If you notice, our vapor pressure here, it involves temperature. So we can say that PA VAP is equal to, if we put a 10 in the front here, 10, we can say that PA VAP is equal to 10 raised to this piece right here for each one. This way, we will ultimately solve for T because we know P, we know XA, we know XB, we know everything else. We just don't know T. And so let's do this problem in Excel. The way we're going to solve this problem is by kind of guessing a bunch of temperatures. So we got T, and then we can do PA VAP. That's Antoine's equation. PB VAP, Antoine. PC VAP, Antoine. PD VAP, Antoine. And then we can ultimately get, let's go back to the equation. And so looking at the second equation, we know that this piece right here is equal to YA, YB, YC, YD. And we know that YA, YB, YC, YD is equal to 1. So YA, YB, YC, YD. And finally, we will sum up YA, YB, YC, YD to equal 1. Whatever situation equals 1, that will be our bubble point temperature. Okay, so we're going to kind of guess, say 150 to 155, and just get a bunch of numbers. Next, we will do our equation. And we know it's going to equal 10 raised to negative 820 divided by our temperature plus 4.4, close parentheses, enter. We do the same thing for the rest. So we would get is equal to 10 exponent, we will have negative 1050 divided by temperature plus 4.5, close parentheses, enter. Next, equal 10 raised to parentheses. We will have negative 1300 divided by our temperature plus 4.6, enter. Next, 10 raised to parentheses negative 1200 divided by temperature. I need to put an equal sign here. Divided by temperature plus 4.5, close parentheses, hit enter. Next we'll do YA. So is equal to parentheses. We have 0.05 times our PA VAP divided by our fixed temperature, which we said was 4. Close parentheses, enter. Next is equal to parentheses 0.1 times our this value right here, PB VAP, divided by 4. Hit enter. Next is equal to parentheses 0.4 times our PC VAP divided by 4. Hit enter. Next is equal to parentheses 0.45 times PD VAP divided by 4, close parentheses, hit enter. Finally, we sum up YA, YB, YC, and YD. So it's equal to sum parentheses YA, YB, YC, YD, hit enter. And now we need to highlight all of this piece, hit the crosshair, and go all the way down to our 350 here. Okay, so here it's getting pretty close. Let's highlight it. So we know it's going to be between 285 and 290. So now I can simply just change these values to get closer. Say 286, 287, 288, 289. Okay, now we can see it's going to be between 288 and 289. So I can even get more closer. So say 288.5. Okay, that's good. We can get even better. 288.4. Okay, and let's do, so actually this first one is actually better. So we can try one more, 288.45. Okay, so now 288.45 seems pretty good. So this right here will be our bubble point temperature. So let's write this down. So T bubble will be 288.45. And now we can solve for the vapor composition that results. So right now we got the first part of the answer, bubble point temperature, which is this. Now we want to know vapor composition. So we want to know YA, YB, YC, and YD. And we already did that in Excel. So let's pull up Excel again. So our YA, YB, YC, and YD will be this. And that's all we need to do to solve a quaternary mixture in order to get the bubble point temperature and the vapor composition.